Welcome to this comprehensive guide on LINQ, or Language Integrated Query, designed specifically for beginners. LINQ provides a unified way to query data from various sources using a common syntax within C# or VB.NET. It allows developers to write queries to retrieve, manipulate, and transform data from databases, collections, XML, and in-memory objects. One of LINQ's primary benefits is offering a standard syntax for querying any data source, bridging the gap between relational data and the object-oriented world. This enhances code readability, reduces clutter, and improves reliability through C#'s robust type system. LINQ providers are essential. They map LINQ queries to the specific data source, translating them into commands the source can execute. To begin using LINQ, you must import the system, LINQ namespace into your C# project. LINQ offers two main syntaxes: query syntax, which is similar to SQL, and method syntax, utilizing method calls and Lambda expressions. Both syntaxes are semantically identical, but query syntax is often considered simpler and easier to read for many developers. Here's an example of query syntax to find even numbers from a list of integers. And this is the equivalent method syntax, achieving the same result using extension methods and a Lambda expression. Basic LINQ operations include filtering, which selects elements meeting specific criteria like where. Sorting operations like order by and order by descending arrange elements in a specified order. Projection, using select, transforms a collection into a new form, allowing you to pick specific properties or create new objects. Aggregation functions like sum, average, min, and max compute a single value from a collection. Finally, group by organizes elements into groups based on a common key, useful for categorizing data. Now, let's explore how LINQ is used effectively within Visual Studio for various data handling tasks. LINQ to objects allows you to use LINQ with any IEnumerable or IEnumerable ticket collection directly in memory. Consider this example: filtering a list of names to find those starting with C. The where clause efficiently selects only the names that meet our specified condition. Another practical example is calculating the sum of numbers from a list of scores. The sum extension method provides a concise way to achieve this, outputting the total score directly. LINQ heavily utilizes extension methods, which add custom functionality to existing types without modifying their source code. Next, we'll see how LINQ can be integrated into Unity 3D for game development, enhancing data management. In Unity, just like in Visual Studio, you need to import the system, LINQ namespace at the top of your C# script. LINQ can be incredibly useful for finding and manipulating game objects efficiently within your scenes. Here's an example of using LINQ to find all active game objects tagged enemy. This code snippet efficiently filters out inactive enemies, providing a clean list for further processing. LINQ also simplifies managing inventory systems, allowing easy querying of items. For instance, you can quickly retrieve all consumable items from an inventory list. The debug log then confirms the names of the retrieved potion items. Real-time examples include using LINQ to find specific objects in a game scene or organizing complex game data. You can also filter game objects based on various properties, such as high scores. Let's now delve into helpful tips and crucial performance considerations when using LINQ. Be mindful of performance overhead, as LINQ queries can introduce additional processing, especially with complex operations or large collections. To mitigate this, cache the results of LINQ queries where possible to avoid re-evaluating them multiple times. For simple operations, consider using traditional loops, as links overhead might be unnecessary. During its first execution, LINQ can be slower than traditional sorting algorithms due to just-in-time compilation. However, subsequent executions often show LINQ performing significantly faster, sometimes nearly 10 times quicker than bubble sort or tree sort. Unoptimized LINQ usage can lead to significant memory allocations and increased garbage collection costs. Each call to .list creates a new list, negatively impacting performance, especially with large datasets. Optimizing LINQ methods by removing unnecessary .list calls can lead to noticeable improvements in memory efficiency. Let's explore some common and powerful LINQ operations that simplify data querying. The any method checks if any element in a collection meets a specified condition, returning a Boolean value. In this example, name found would be true because Jared is present in the array. The distinct method removes duplicate elements from a collection, providing a unique set of values. The output clearly shows only the unique numbers 1, 2, 3, 4, and 5. First returns the first element of a sequence that satisfies a condition or throws an exception if none is found. First or default is similar but returns a default value, such as null for reference types or 0 for integers, if no element is found. In conclusion, LINQ simplifies data manipulation tasks and makes your code more efficient and readable. Its unified syntax across various data sources is a powerful tool for any developer. We encourage you to experiment with LINQ's diverse features to discover how they can simplify your code and enhance your game development process. Always remember best practices. Use profiling and analysis to select the method that best meets your project's needs. This ensures smooth gameplay and an enhanced user experience, balancing code readability with optimal performance. Thank you for watching this guide on LINQ for efficient data handling in Visual Studio and Unity 3D.